I want to save the last type of solving radical equations for its own day because they're the ones that are a little more involved, and I wanted to spend enough time going through multiple ones so you're comfortable. So first, a definition. You're going to hear in Algebra 2 more than in Algebra 1 of something called an extraneous solution. An extraneous solution is a fancy way of saying basically you do everything right, you solve exactly the way you're supposed to, and yet an answer, or sometimes answers, end up not checking out whenever you plug them back in. So we've been talking in the last couple of videos, you get your answer at the end, x equals 5, you put 5 back in, and you show that both sides are equal. Well, this would be a situation where you do that, you do everything right, but the number that you try to plug back in does not make both sides equal. It doesn't happen often, but it happens in a very specific situation. So the situation that it happens in this chapter is when you have a square root equation that has variables on both sides. If you look back to all the ones we did in previous videos, we had a square root or we had a fractional power, and we only had x show up once. When you have variables on both sides and you have a square root equation, it is possible that you will get an answer or multiple answers that are extraneous. So let's get to how these work. So your first step is to isolate. So I'm going to kind of make a little list at the top. Our first step is to isolate the square root. So we're going to do that by adding 5 to both sides. So you get the square root of x plus 7 equals x plus 5. Your second step is to square both sides. And this is going to take a little more work than it did on the previous ones. So when I square both sides, the left side, the square root side, is going to be easy because the square and the square root will cancel. But on the right side, when you're squaring x plus 5, you're not allowed to just square both of them individually. You have to FOIL them out when I square, because that's how we multiply a binomial by itself. So we're going to have to come off to the side and write down x plus 5 twice. So we can see what happens when I FOIL x plus 5 times another x plus 5. They should be easy things to FOIL. That's the nice part. So x times x, your first is x squared. The outer is going to be 5x. Your inner is also going to be 5x. And your last is going to be 25. So again, first, outer, inner, last. You want to combine like terms. So when we do this, I'm going to come back to my work over here. I get x squared plus 10x plus 25. So squaring both sides when you have a binomial and you have a variable is more work than just squaring a number that you can pop into your calculator. Once you have that done, you're going to want to get it in standard form, which means you're going to want everything equal to 0. Now, I would take whatever side has the x squared, keep that where it is, and have everything else join it. So I'm going to subtract x and subtract 7 over here. So I have x squared plus 9x plus 18. Once I get to this point and I have it in standard form, we should be able to factor this. I'm going to try to stick with ones that are easy to factor and not ones you have to use your quadratic formula to solve. So I'm looking, this is basic FOIL factor, numbers that multiply to get 18 and add to get 9. That would be 6 and 3. So you get x plus 6 and x plus 3. So your two potential solutions, and I'm going to call them potential because we could end up with an extraneous, is -3 and -6. So here's how we check and see if -3 and -6 are actual solutions or if one or both of them end up being extraneous. Calculator is going to be really helpful for this. So you're going to pull out your calculator. You're going to, one at a time, take your value of x and plug it into the original equation to see if both sides are equal. So your original equation is the square root of x. So I'm going to check -6 first, plus 7. And then I'm going to get out of the square root, minus 5. And if this is truly a solution, it should equal my x value of -6. And it doesn't. It equals -4. So that is an extraneous solution, meaning it is not something I should list. If I'm doing delta math, it is not something I should type in. Now let's check -3. So I'm going to take the square root of -3 plus 7 and then minus 5. And I do get -3, which is what my x value is. So that is how you check to see if a solution is extraneous. It is truly so much easier with a calculator than trying to do it in your head. Anything that is extraneous when it comes time to list solutions, like on a delta math problem, you don't list them. You only list the solutions that were valid solutions. So let me show you some more of these. So isolate the square root, subtract 3. So we get the square root of 5x minus 1 equals x minus 3. Square both sides to get rid of the square root, and here's where the foiling comes in. So I like to do my foiling off to the side so that I'm kind of save some work where I'm working. So first is x squared, my outer is negative 3x, my inner is also negative 3x, and my last ends up being positive 9. You'll notice when you FOIL out binomials that are identical, your outer and inner will be the same. They don't cancel, they just combine. So we have a negative 3x and another negative 3x, which is negative 6x. So coming over here, I have 5x minus 1 equals x squared minus 6x plus 9. I'm going to get everything on one side, so I'm going to subtract 5x and add 1. Subtract 5x and add 1. So I get x squared minus 11x plus 10. I need numbers that multiply to get 10 and add to get negative 11. That's going to be a minus 1 and a minus 10. So my two possible solutions are 1 and 10. So I'm going to grab my calculator, move this over so you can see, and I'm going to check each solution. I always go back to the original equation when I check solutions. So I'm going to take the square root of 5 times, I'll check 1 first, 1 minus 1. Oh, that's all should be under the square root. Hold on. Let me start over. Square root of 5 times 1 minus 1 plus 3, and that should equal 1. It doesn't equal 1, it equals 5. So that is not a solution. And let's try the other one. So let's try 10. So the square root of 5 times 10 minus 1, get outside the square root, plus 3, that should equal 10, and it does. Now, a lot of times students will ask, do you have to have one of each? And that's not the case. You will have situations where both solutions end up working, that when you plug them in, they would check out just no problem. You're also going to have situations where neither of them work, where you'd have no solution. In that case, you would type in like empty brackets in your delta math to show that. The most common is to have one solution work and one not, but you definitely can have other options that happen. So let me take you through these two. This next one's going to be a little bit easier. We're going to add x to get, this is a square root. I know we have it written as the 1/2 power, but the 1/2 power and the square root are the same thing. You're going to square both sides to get rid of the 1/2 power. This one's going to be easier because there's nothing to FOIL on the right side. You just get x squared. I still want everything to be on one side though, so I'm going to subtract 5x and I'm going to add 4. I'm going to get everything over here. So I get x squared minus 5x plus 4. So I need numbers that multiply to get 4 and add to get negative 5. So that's going to be a minus 1 and a minus 4. So my two potential solutions are 1 and 4. And then on my calculator, I'm going to check 1 first. So parentheses 5 times 1 minus 4 to the 1/2 power. You're going to type it exactly in as you see it. And I want to then minus x was 1 and see if that equals 0. It does. So that is a good solution. A lot of times I either like circle it or I put like a check mark next to it to show that I checked it. So now let's check 4. So 5 times 4 minus 4 to the 1/2 power. To the, sorry. I don't know where my cursor went. To the 1/2 power. And minus 4. See if that equals 0. It does. So this is a situation, as I mentioned a second ago, where both solutions are valid. So when I'm typing it in delta math, I want to make sure I type both because they both end up being valid. My next one, I'm going to subtract 5 to get that isolated. So I have x plus 7 under the square root equals x minus 5. I'm going to square both sides. So I get x plus 7. I'm going to come off to the side and do x minus 5 times x minus 5. You may be getting to the point where you can do a lot in your head, and that's fine. So I have x squared minus 5x minus another 5x plus 25, which ends up giving me x squared minus 10x plus 25. Bring everything on one side. So I end up with x squared minus 11x plus 18. So I need numbers that multiply to get 18 and add to get negative 11. So that's going to be a minus 2 and a minus 9. So my potential solutions are 2 and 9. So to check each of them, doesn't matter which one you check first. I'm going to check 2 first. So the square root of 2 plus 7 plus 5. Let's see if that equals 2. It doesn't, so that's out. So now let's check 9. So the square root of 9 plus 7 plus 5. Let's see if that equals 9. It does. So we have one valid solution of 9 and one extraneous solution. I've got 2 left. The last one is actually the easiest one, so we'll finish with the easiest one. This next one is already isolated. This one I took straight from Delta Math because I wanted you to see how they set this up. So we can immediately go to the squaring process to square both sides. So we have 8x plus 52. This side I have to do x plus 8 times another x plus 8, which is going to give me x squared plus 8x plus another 8x plus 64. So when I combine like terms, I'm going to get x squared plus 16x plus 64. I want to get everything on one side, so I'm going to subtract 8x and I'm going to subtract 52. So I get x squared plus 8x when I combine my x's and plus 12. So I need numbers that multiply to get 12 and add to get 8. So that's going to be 2 and 6. So x plus 2, x plus 6 is my factored version. My 2 possible solutions are -2 and -6. Grabbing a calculator. I'll do -2 first. So the square root of 8 times -2 plus 52. Oh, I wanted that square root to go over the whole thing. 8 times -2 plus 52. There we go. And I want to see if that equals -2 plus 8, which it does. Both sides end up equaling 6, so -2 works. So now let's check -6. So the square root of 8 times -6 plus 52. That equals 2. And then if I take -6, the other side is -6 plus 8, also equals 2. So this is another example where we had 2 potential solutions and they both were valid. So you would type both in. Last question of the topic. If both sides have a square root, this is actually the easiest one that you'll see. If both sides have a square root, when you square both sides, it will cancel the square roots on both sides of the equation. So you will end up with just 3x on the left and x plus 6 on the right. We're going to subtract x. 2x equals 6. Divide by 2. We get x equals 3. To do a quick check to see if both sides are equal on this, because I did square both sides, I get the square root of 3 times 3, which is 9, and on the square root of 9, which is 3. And then on the right side, we get the square root of 3 plus 6, which is also the square root of 9, which is 3. So this one only had one solution, and it was indeed valid. So that is the end of 6.5. You will notice in the Delta Math, you will have more problems that do have extraneous, and they have a little more work. You won't do as many as you did the day before because they are a little bit longer, but expect some extraneous and some valid ones all mixed together.